What's up, everyone? This is LeetCode 139 word break. So we're given a string s and a dictionary of strings word dict. We have to return true if s can be segmented into space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Right, so basically, can we create the string s from the strings in word dict, and we can use these words more than once. In example one, we can create the string LeetCode, right? So we return true because we can use the strings in word dict leet and code to create LeetCode. So we return true. Here, right, we can use apple, pen, and apple to create this string s, so we return true also. Example 3 is a bit odd, right? We can use the word cats and, but then we have OG. We have the word dog, but we have to use the entire word, so we can't use this word. We could also try cat and sand, right? Cat, sand, but again, same scenario. We have OG left, but we don't have a D, so we can't use the word dog. And so we return false because we cannot build out the string s from any sequence of strings in word dict, right? So I think this problem statement is kind of simple. It's just like the implementation for this problem is a little bit tricky, and yeah, actually, it's actually a tricky problem, but it seems easy on the surface. Okay, so given that you're on this video, you probably tried something like a two-pointer approach, right? Like a sliding window, right? Where you expand your sliding window, right? So if we have something like this, where this is our word dict here, this is our string, right? If we have something like this, you might think, okay, Lee is a word in our string, or in our word dict, right? So let's move our sliding window over, right? And then you might look at like some of the substrings here. I can't speak. Some of the substrings here, you might look at it and you realize, okay, none of them exist in word dict. So you return false. But that's not the case, right? Because technically you can build out this string s by doing leet and code. But given that you're using a sliding window, you looked at Lee first instead of leet, right? So you should actually be returning true here, not false. And the problem with like a sliding window approach is there's just a lot of edge cases where that you have to account for, right? And so like a sliding window two-pointer approach is not efficient for this problem. It's going to trip you up on a lot of like test cases, and I know that because I tried that. Um, so yeah, this problem is actually trickier than it seems. And this problem is actually a DP problem, right? That's how you solve this problem. You use DP, right? Dynamic programming. So I'm going to walk through that, and I'll try and explain as best I can. It's a little bit of a tricky problem, but I think I'll try and go slow and explain stuff. But yeah, okay. So we have our string s, right? And we're gonna have to create a DP array. So we're gonna create. I don't know if I can minimize this. Whatever. But anyways, this just says DP right here. So this is our DP array down here, and the length of the DP array is the length of s plus 1. Oh, if I draw, it goes away. Okay. So the length of s is, we take the length of s plus 1, and that's the length of our DP array. So our DP array is a little bigger. And this DP array here is actually a Boolean array, and everything is initialized to false initially. Okay. Initialized to false initially. That's a bit redundant. But everything is just false in this DP array, okay? Initially, except for the 0th index. That's actually true, because this is kind of like our base case, like our starting point for our algorithm, and it'll make more sense why we do this. But this is our DP array, right? It's a Boolean, and this is just the initializing part, okay? We haven't done anything special yet. And so the point of the DP array is we're going to basically build out combinations of words, right? We're going to look at the different possible combinations of words, because like up here, right? Like we technically could have leet, right? Like imagine we have some word like TCO also, right? We could like have this combination here, then this combination here. But however, we can also have the combination leet and code, but we need to find the proper combination that actually can build out the entire word, not just the partial like segmentation, right? It has to be the full segmentation. We have to build out the entire string, right? And so the point of the DP array really is like if we get to this ending point here and this gets set to true, it means we found some combination of strings in word dict to where we can build out the entire string s, okay? And so this DP approach is very efficient for that. Okay, so the way we're going to do this is we're going to basically have a starting point, which is we're gonna iterate through this string s, okay? And we're gonna do that in a for loop. So we're gonna have an I, right? That's gonna start here initially. And so what we're going to do as we iterate through this, right? Initially I is at 0, right? Because we're in a for loop. And what we're going to do is we're gonna check wherever I is at a given point, like now. Now we're gonna check dp of I, okay? So what we're really checking is dp of 0. And if that's true, then we need to do something, okay? So let's go dp of 0, and oh, what do you know? dp of 0 is true, right? This is our starting point, so this should always be the case, right? Like I said, this is our base case for our algorithm, which is why this has to be true initially. So dp of 0 is true. Okay, so what we're going to do now is we're going to basically have a j variable, right? And j is going to be at I plus 1, okay? Now, in terms of like, because what we're doing now is we're going to look at certain substrings to see if they exist in worddict. Okay, now wherever j is now, you need to understand where should j end, right? How far should j go out? Should it go all the way out to here? I mean, think about it. Should it go all the way out to here every time? In every case? And the answer is it depends. Because you need to think about something in terms of efficiency for this algorithm, which is that when we're looking at substrings, we never want to have a substring that exceeds the longest length in worddict, right? For example, the length of the longest word here is size 4, right? Size 4, right? So when we're looking at like substrings, would we ever want to look at a substring like this long? Well, of course not, right? Because we would never have a substring that's of length 5 when our longest substring here should be 4, right? So why would we ever want to look at a substring that's of length 5, right? So we actually don't want to go this far out, right? And the reason I say it depends is because let's say our array ended here. Well, technically we don't want to look at a substring like this because we'd be out of bounds, right? So we basically want to take the minimum between the length of s and the longest length of the substrings in worddict, right? Yeah, the length of the longest word in worddict and the length of s, right? We have to take the minimum. Okay, and that's just like an efficiency thing. It'll make more sense in when we write our code, but I just want to mention that just so I don't drop it on you later and you're like, well, where did this come from, right? So I'm just kind of explaining that visually. But anyways, so technically, where should j end, right? So as far as j, right, in the for loop, in the inner for loop, j is going to start at I plus 1, right? And it should end at I plus 1 plus the longest length of the word in worddict, the length of the longest word in worddict. So this would be 4 plus 4 plus I is at 0 plus 1, so it should be at 5. So j should technically end here, but remember, in for loops, at least in Python, we technically, this is not inclusive, so our j technically goes here. This is our last index that we're going to touch. But because we're using Python, when we do string splices, right? When we do from 0 to 4, right? Remember, you need to keep in mind how string splicing works in Python, right? This is inclusive, this is exclusive. So the way this would work, right? And the way this would work is we're technically going from 0 up to index 3. Okay? So this is our longest substring. So because this is how string splicing works in Python, right? When we do from index 0 to 4, we're including index 4 but not index, we're including index 0 but not index 4. So technically we're going from 0 up to but not including 4. So we go from 0 to 3, and that's the length of our longest string in our substrings. The reason I mention all that is just I don't want to get you confused because, technically j is going to go up to here, but we're not going to include this index because you might look at this and go, wait a minute. Our longest substring should be 4, right? Not 5. Why is j up here? And it's because of how string splicing works in Python. Okay. But anyways, that was just kind of some preliminary tangential stuff to make sure you don't get confused, just to keep in mind on how we're going to make this algorithm efficient, right? So let me just go back to where we started. Okay. So I is at 0. We go to dp of I. That's true. Okay. So now we can go into an inner for loop. So we're going to set j to start at I plus 1. So j is going to start here. Okay. And we're going to say we're going to string splice from I to j, right? So from 0 to 1, but remember this 1 is not inclusive. So technically we're going from 0 to 0. So we're looking right here. Okay. Is this in our word dict? The letter L? No, it's not. And again, this example here, that is just this, okay? I'm just using this. So no. So we can move j over. Okay, so from 0 up to 2, but this, remember, the string splicing doesn't include this index. So we're looking at this now. LE is not in there. Okay, now we move here. Okay, is this in our word dict? It is. So what we're going to do now is we're going to set dp of j to true. So dp of 3, right? So 0, 1, 2, 3. So now dp of 3 is going to be set to true. Okay, so now we move here, right? And again, we're looking at this substring now. Is this in our word dict? Yes, it is. So we set dp of 4, right? Because we're at index 4. Now we set dp of 4 to true. So we set this to true. And as you can see, in this approach, we're looking at both these substrings now, or both these words, right? Whereas like in the sliding window, we were only looking at this, or maybe you do like some weird like edge case handling where you handle both, but it just gets really confusing when you have a lot of test cases. And this is just more efficient, okay? So now, remember, our sliding window substring should only go up to length 4. So now we're done with this part. So we're going to basically, we're going to move I forward, because remember, the whole point of this is that we're in a for loop checking every moving forward in the string s, right? Going like kind of linearly. So now we're going to move I here. So I at index 1. So dp of 1, well, that's false, so we're not going to do anything. So move forward. dp of 2, that's false. dp of 3. Okay, now this is true though, right? Because we look here and this is true. So now we're going to have to set j here, and we're going to basically look at this substring, at this substring, at this substring, at this substring, but we're not going to find anything, right? Because none of those substrings exist up here. So technically, it doesn't really matter. We're still going to look through it, obviously, in our code. Like, our code's going to run through it, but we're not going to find anything. So we move forward, right? And now we're at I is equal to 4. Well, dp of 4 is true, right? So we need to do the same thing. So set the j here, and we're going to look at this substring. It's not in word dict. This substring, not in word dict. This substring, not in word dict. This substring is in word dict, right? So because this is in word dict, we're gonna, when j is here, when j is here, right? We're going to basically put this here as true, right? Well, technically j is not at the 7. Sorry. Because remember, the way string splicing works is up to but not including. So technically, to include these 4, j should be here. So it should be at index 8, which we do have an 8 in the DP array. So this gets set to true, right? And then we keep going, right? I is right. I is gonna keep moving forward. So DP of 5. Is false. DP of we go a 6 is 6 false. Is DP of 6 have anything? No, it's false. DP of 7, no, it's false. And obviously we're dumb, so we never check DP of 8. But remember what I said? Like the last index is super important. This is true. So what does this mean? It means that we found a combination of words that we can build out the string s, and we did, right? And so you can see with this DP approach that it's really beautiful because we're looking at the subs. So we found Lee, right? And then we check if we have we can build out the full word from here also. But at the same time, because we're using DP, we're also checking this and see if we can build out the word from here. So we're really looking at all the combinations. And if, like when we find a certain substring like Lee, okay, let's look at all the combinations from there onwards. Oh, when we find leet, let's look at all the combinations from there onwards. And so we're kind of looking at every combination, right, wherever we find substrings. And so that's why DP is so efficient here. Okay, so I hope this illustration helped. I know this video is a little bit long, but like I really want to run through this visually because it just makes the problem so much easier to understand. So if I write the code out, it's not going to make that much sense. But I think it should make sense now. Okay, and I'm going to write some comments just in case you're still slightly confused, right? So basically, start at the empty string, which is basically DP of 0, and find the words that can be built from there. Mark the ending index as true, and keep doing the same process, basically. If at the end that index is true in DP array, it means there are words that can be used from wordDict to form string s. So it should return true. Otherwise, return false. Okay. So that's basically how we're going to check if like if we can build string s from wordDict. Is if this index here, when we're done with our algorithm, if this last index here is true, it means we can return true. Otherwise, we return false. Okay. Okay. So remember, we're going to set up our DP array. So we're going to say everything initially is false, and remember the length is going to be the length of s plus 1. Okay, so we're just creating the DP array and initializing it. Remember, DP of 0 is kind of like our base case. That should be true. Okay, and so we're going to say for I in range length of s, right? We're going to iterate through the string s linearly. And remember what I said, we need to find, for the purposes of j, as far as how far j out should go, we need to find the length of the longest word in wordDict. So let's actually do that really quick. Okay, so we're going to say the max word length, and we're going to say max length of the word or word in wordDict if wordDict else 0. WordDict length 1. So I don't think we need this because there's not really an edge case where wordDict can be basically empty. Right? So we technically don't need this. And I'll write some comments, right? So when checking substrings to see if a substring in S is in wordDict, we don't want to expand our substring to exceed the length of the longest word in wordDict. That is just inefficient and a waste of computation. So let's keep track of the max word length in wordDict so we don't exceed this length when checking substrings, right? Here's another thing we're going to do, and this just makes our program slightly more efficient, is when we're like getting a substring like LE, right, or LEE or LEET, we're going to basically check if this exists in wordDict. But the thing is, like, wordDict is just an array, right? And so when we do a comparison, like, does this substring exist in wordDict? It's going to be slightly inefficient. So to make it more efficient, we're going to convert wordDict to a set, right? Because that way our lookup is going to be O of 1, right? So we're going to say use set for O of 1 lookup, right? Just to make it slightly faster, because lookups in sets are really efficient, right? And this is kind of like our base case. We'll just call it that. Okay. So remember what I said, when we're iterating through the string s, wherever I is at, we're going to check if that index is true, set to true in the DP array. So we're going to say DP of I. We're going to say if DP of I, or maybe even more efficient, we're going to say if DP of, or you can say if DP of I, or else you can say if not dp of I, right? Continue, like keep going forward, and then down here do it. You would write whatever, which is where the case where dp of I is true. But we'll just do it this way. We're gonna say if dp of I, right? And remember, this is how we set up j. So remember, the starting point for j is going to be I plus 1, and the ending point is going to be I plus 1. And let me not do it next to each other because it might look confusing. So we're going to do I. Oh, or not I, sorry. We need to take the minimum, remember? Because either we can go, it really depends on how long our length of s is. So the minimum is going to be between 1, I, or sorry, not 1. We're going to say the minimum can either be I plus max word length plus 1 or the length of s. Okay. And here's where we do basically the splicing. So remember, j is not inclusive, it's exclusive. And we do word dict set. And remember, this is why we do the set, so our lookup is super fast. And so if this substring exists in word dict set, then we can set the dp of j to true, right? Remember the illustration I showed you? That's all we're doing. I'm just writing it in code now, right? You can feel free to go back if you want in the video. But that's it. That's literally all our code is, right? And then here we can do dp of -1 to get the last index in the dp array. Or alternatively, you can just do something like return dp of length of s, right? So that should work. Unless I'm missing something, but we don't need this here. I initially had this here, but I don't think we need it because word dict can always be, word dict will never be 0, or it will always exist. I mean, forgot to say in. Okay, let me see what I missed. Oh, sorry, we need to do length of s plus 1 because remember, the way our string splicing works, this is exclusive, so we need to make sure we get the last index as well. If we have a word like word, right, we need to make sure the j goes up to 0, 1, 2, 3, 0, 0, 1, 2, 3, right? So the length of s, so that'd be 4. So 0, 1, 2, 3, 4. We want it to go here, right? And the reason we want it to go here is because technically, so the reason we want it to, so technically, like, I'm not explaining this well, right? So these are our indexes 1, 2, 3. Let me space this out, right? We want j to not go to 4, but to go to 5 in our for loop, because remember, this is exclusive as far as our for loop goes. So technically j is going to go here, right? So technically j is going to go at this 4. When it goes up to 5, but it's not inclusive, right? So technically j goes from 0 up to and including 4. However, the string splicing will go from 0 to 4, but 4 is not inclusive, so it'll look at all this. So this is not inclusive, but our string splicing is also not inclusive. So we actually need j to go up to 5 as far as setting it right here. So we need to do length of s plus 1. I know it's kind of weird, but it's just the way Python works, right? Like this is not inclusive, neither is the string splicing. So we need to make sure j doesn't go here, but it actually goes up to here. It doesn't go up to there, but I mean set this here up to 5. I hope that makes sense, right? It's just Pythonic, but hold on, this is loading. Let me retry this. I think LeetCode is just really slow. There you go. Now we can submit. And there you go. Yeah. Quite a few ways to solve this problem, by the way. So, you know, if you find another solution more intuitive, go for it. But it was pretty efficient. But there are a few ways to solve this problem. Anyways, I hope this helped, and I'll see you in the next one. Peace out.